Welcome. So in this video tutorial, we are going to see about the research tool, that is principal component analysis. So principal component analysis is a correlation analysis. So here I am going to show you how to plot the graphs of the principal component analysis and how to interpret the obtained data in your research paper. Okay. So when principal component analysis can be applied, if you have the research data, if you have the different kinds of variables that you have analyzed, and if you don't know the correlation in between them, whether they are positively correlated or whether they are negatively correlated, and also whether their respective treatments, whether they are uh, whether they are significantly differ with respect to their attributes or not, that we are going to see in this tutorial. So first, here I am going to give one of the example of my research data so you can understand each and every concept, or you can correlate this with your research. So this is what the data which I have put it over this one table format. Here you can see in this Excel sheet. So likewise you have to do to analyze PCA graphs for your research paper or research data. Okay. So what you have to do, just select whatever the put data. Okay. So this is all about the 17 to 18 attributes that I have put it right here for the respective treatments. So before going to see about this PC analysis, I have to uh, brief you about my research, that I harvested the dragon fruit at various intervals from 20 to the 40 days at every 5 days of intervals, and I have analyzed it for the various attributes like physical attributes, biochemical, bioactive, color characteristics, likewise. Okay. Okay. So the data I have put it in a one table format. Likewise, you have to do. Then I'm going to select all the tables. Here you can see how I'm selecting it. Selecting the whole table, I am here. Okay, once the overall all table is selected, just click over the copy and make paste over the Minitab software. So I'm doing the principal component analysis by using the software, that is Minitab. Okay, once the data is putted, then we have to go to the stats, where you can find the multivariate tool. Go to the principal component tab. Okay, then select all of the variables for which you want to draw the PCA graph. Okay, so click over the shift key of your keyboard and select all the variables. Then click over the select. Once all the attributes get selected, then go to the graphs. Before going to the graphs, make sure you have to tab over the correlation. It is already tapped over the correlation matrix, because PC analysis is what? A correlation analysis. Then go to the graphs, select the plots that you wanted. So I'm selecting here all of the graphs. Later on, I am going to discard some of the graphs for the better visibility and better understanding to all of you. Okay, click over OK. So here I'm getting the different graphs. In the biplot graph, you can get the treatments along with the attributes, their positive or negative correlation. We don't want this graph. You can't get the concept that what I am saying to you, because of which I am discarding this graph right now. Okay, keep this graph, that is loading plot. I can keep this core plot of the treatments, that I am discarding this third plot. Okay, so these from this graph, how you can interpret your research data, that I'm going to show. First of all, you have to label whatever the treatments that is shown by the that circular tab. Okay, just add the labels to it. Go to the data tables, then use labels from your column, whatever the okay. So then click over the treatments. We have entered the data already in the Minitab software. Then treatments, that is the independent factors. Okay, before going that, click over the treatment and select it. Then click over the OK. Okay, so here you can see the labels of the treatments that we have put it in the Minitab software. Okay, just adjust it according to the way you want it, according to your suitability. Okay, so how you can interpret these obtained graph? Okay, here you can see earlier what I have told you, that whatever the dragon fruit I harvested at different days of interval from 20 to 40 days after flowering. So here you can see the distance between the two quadrants, that is 20 days of fruits harvested at 20 days and the fruits harvested at 25 days, is much bigger when compared to the distance in between harvested fruits of 25 days and 30 days. So what it signifies, whatever the difference in between their qualitative attributes is what highly differ. Okay, whatever the qualitative attributes, they are what significantly or highly differ in between these two periods or in between these two treatments, where the qualitative attributes which are at the different quadrants, that is at 25 days after flowering and 30 days after flowering, both of they are what significantly different from each other. But whatever the significant difference is not much more when compared to these two treatments, because they are what somewhat closely spaced when compared to this harvested period or these two treatments. Then thereafter, here you can see the two of the treatments, that is fruits harvested at 35 days after flowering and the fruits harvested at 40 days after flowering, are lies on the what same quadrant. What it signifies, what it denotes. So it denotes that whatever the qualitative attributes analyzed between these two treatments or during this period of harvesting is what less significant or not significant. Okay, so this is what the interpretation. So which are the qualitative attributes based on which these significant differences denoted are what correlated here in this graph. You can see whatever the variables or the data which is on the positive sides are what positively correlate with each other, whereas on the other hand whatever the data which is put over on the negative sides, they are what negatively correlate. What it means, what it indicates, so whatever the data which is on the positive side is what getting increased with respect to harvesting period. So the attributes like TSS, pH, redness index, that is denoted by A, beta cyanine content, chroma value, that is denoted by C value. Okay, so these are what getting increased. Here you can correlate with the obtained data which I have put it here in this software. Here you can see the C value. It is what getting increased. That is why it is on the positive side. Okay, next here you can see the TSS acid rush. It is what also getting increased. That is why it is on the positive side of the principal component. Again, TS is also what getting increased. That is why it is on the positive side. Whereas the rest of the attributes here you can see on the negative side, they are what getting increased with respect to treatments. That is why their levels is what getting decreased. Here you can interpret with L values. Here you can see it is getting decreased with respect to treatments. So this is what all about interpretation. And also the one of the more important component here is the variability. Based on variability only you can employ this principal component analysis. Okay, if the percent variability of your data, if it is more than 70%, then only you can apply this principal component analysis. How you can get to know how you can get to know the percent variability is above 70%. Okay, here you can see this is what the eigen analysis of the correlation matrix. Here you can see the proportionate values have been given. Okay, so proportionate value of principal component one, it is what 0.927. Okay, so go to the calculator tab. Then calculator calculate. Then 0.927 multiply it with 100. So you can get the percent variability of first component. So 92.7 is the percent variability of your first component. Then go to the second tab. Here you can see the proportionate values of 0.050. 0.050 multiply it with 100. That is percent variability is what? 5%. Okay. So what you have to do? You have to put the percent variability by clicking over it into the bracket. So first component percent variability is about 92.7%, whereas that of second component principal variability is of about 5%. If you summate those of the two components, the percent variability is about 97.7%, which is what higher than that of 7%. So these principal component analysis for my data is what well fitted. Okay. So this is how you can do. Let's see how we can format these graphs. Okay, let's format this principal component analysis obtain graph. Let's delete this. If you want to change the color, you can change or you can keep the way you want it. I am doing by my way. Make it to the white. Okay. If you want to change the font, then you can. Here I am using the Times New Roman font. You can adjust according to the way you want it. I am changing the color of each of the treatments. Okay. Again, I am changing the font. I am changing the type of so the size of the x and y axis. I'm clicking over the Times New Roman, which is what the standard format. You can choose the way you want it. Whatever the format, whatever the font you want, you can choose according to the wants and needs of research paper or manuscript. Color that I am using the standard black color. Okay, one thing is remain. Choose the size of that line. Make it to the 3. Okay, cool. Color is remain to select. Okay. Okay. So this is all about the formatting. Similar wise, you can do the formatting this to the another table that is loading part. So here you can put the whatever the principal first component variability and the second component variability. Likewise, okay. So this is all about the today's tutorial, which is on principal component analysis. That we have seen how it is performed, how you can interpret the data in your research paper. Thank you.